Welcome to the Chapter 1.2 lesson video. We're going to be talking about systems of equations. This might be a little bit of a review for you because this is something we didn't really talk about much in Math 2, but you first learned back in Math 1. It's something that does come up a bit though, so we want to make sure you are familiar with it. Let's go ahead and begin. If you don't already have your notebook out, take it out so you can take notes just like normal class. We're going to be talking about systems of equations. By the end of this video, you should be able to determine if a point is a solution to a system, and you should also be able to solve a system of equation using three methods: graphing, substitution, and elimination. All right, so first things first, a solution to a system is any ordered pair, any pair of 2 points, x and y, that make all equations in the system true. So here's the question: is 2, 4 a solution to this system? In order to check that, what we're going to do is we're going to substitute 2 in for x and 4 in for y. So this is going to become 4 equals 2 times 2. So I put the 2 in for the x and the 4 in for the y. So the 2 is our x value and the 4 is our y value. Well, let's see. Does 4 equal 2 times 2? You betcha. 4 equals 2 times 2. What about the other equation? Y minus x equals 2. All right, so does 4 minus 2 equal 2? 4 minus 2 equals 2. Yep, that is true as well. So check. Since it makes both of the equations true, when we plug the 2 in for the x and the 4 in for the y, since it makes both of them true, we can go ahead and say, yes, 2, 4 is a solution. All right, so that's how we would check if it's a solution. We plug it in to both equations, and we make sure it makes them both true, or it makes them all true. All right, let's keep going. All right, so if we are trying to find the solution to a system, we have three methods. Our first method is called graphing. Now, if we're trying to find the point that is the same between multiple equations, we're trying to find the point where those equations overlap. So what we're going to do is we're going to graph both these equations on the graph using a variety of graphing methods. If you would like to go ahead and try that, I would encourage you to do so now. Pause the video, and then you can check your answer once it's restarted. All right, so here's what we're going to do. We're going to go ahead and plot the points. The first graph, we'll call it the blue graph. It has a y-intercept of -2 and a slope of 3/2. So that's our rise over our run. So we'll go ahead and put a point at -2, and then we have a slope of up 1, 2, 3 over 2. That'll look something like that. And we can go ahead and draw a line between these points. Our next equation, we'll call it the red equation. It has a y-intercept of +3 and a slope of -1. So that means we go down 1 and over 1, down 1 and over 1, down 1 and over 1, and we can draw our line. What we are looking for is we're saying, what point do these two lines coexist? Where do they overlap? I often like to circle it to show what that point is, and then we write it as an ordered pair. The x value is 2, the y value is 1. That is our solution, 2, 1. Our next method is solving with substitution. To solve with substitution, we need one of the equations to be in x equals or y equals form. If it's not in x equals or y equals form, you can put it in x equals or y equals form. Once it's in x equals or y equals form, you're going to substitute one equation into the other. So you're going to take the part that y equals and you're going to put it where the y goes. You will solve for the remaining variable, and then you're going to take that remaining variable and substitute it back into one of the other equations. Always write your final answer as an ordered pair. Go ahead and try this problem. All right, so here's what it should have looked like. You're going to take 2x plus 1 and you're going to put it in for the y. That'll give you x plus 2, and then you put this in for the y, 2x plus 1 equals 17. you can take that 2 and distribute it to the parentheses. If this was a negative, make sure you if this was the negative, make sure you distribute the negative as well. In this case, it's not. So that'll give you x plus 4x plus 2 equals 17. Let me go ahead and clean that up. It's a little sloppy. 4x. Combine your like terms. That's 5x plus 2 equals 17. Subtract the 2. 5x equals 15. X equals 3. So you have part of the answer here, x equals 3, but what you have to do now is you have to take that value and you're going to substitute it back into one of the equations. I'm going to pick the second equation just because I think that'll be a little bit easier, and I'm going to go ahead and get y equals 2 times 3 plus 1. 2 times 3 is 6, 6 plus 1 is 7, y equals 7. Now I'm not done with the problem. I have not written my answer yet. I got to make sure I write that down. The x value was 3, the y value was 7. I write it as an ordered pair inside some parentheses and box my answer. So substitution, we take one equation, we put it into the other, get one of the variables, and then we plug it back into one of the equations to get the other variable. Our last method is called elimination method or combination method. What you're going to do is you're going to line up your variables and your numbers. So your x's line up with your x's, your y's line up with your y's, and your numbers line up with your numbers. Usually there's the equal sign between the variables and the numbers. You're going to check to find what's called common opposite coefficients. Common meaning the same number, opposites meaning one positive, one negative. If there's not, you may need to multiply one or both of the equations to make that happen. So you can multiply everything through in one or both of the equations to make those common opposites occur. You're then going to combine the equations. So you're going to combine the x's, you're going to combine the y's, you're going to combine the constants. In other words, you just add them together. Those common opposite ones, the ones that we tried to make up here, should cancel out. That'll leave you with one variable that you'll solve and then substitute back in. Make sure you write your final answer as an ordered pair. Go ahead and try this example to the right. All right, so here's what you should have done. You should have noticed that off the bat, we do not have that common opposite. 2x and 3x won't cancel. Y and negative 2y almost, but don't quite cancel. 8 and 5 don't cancel. So what we're going to do is we're going to multiply the top equation by 2. We're going to multiply 2 all the way through that top equation. That'll give us 4x plus 2y equals 16. The reason we chose 2 is because we wanted to cancel out with that minus 2y. We can then go ahead and combine these two equations. 4x and 3x make 7x. 16 and 5 make 21. Divide both sides by 7, x equals 3. We can then take this x equals 3 and substitute it back in for x in any of our equations we get to pick. I'm going to pick the first one because I think that'll be the easiest. So I get 2 times 3 plus y equals 8. 2 times 3 is 6. 8 on the other side, subtract the 6 over, you get y equals 2. We now know x, we now know y, we can write our final answer as a ordered pair, 3, 2. All right, that is our final example. You should be able to go ahead and start the assignment now. If you have any questions, go ahead and bring them up in our class time together. If you have a more pressing question, feel free to reach out over Remind or through email or through Google Classroom, and I'd be glad to help you out. Otherwise, have a great day, and I'll see you in class.